Buongiorno a tutti, scusate il mio italiano non va bene molto tanto, però voglio fare...
C'è di peggio, tranquillo.
Actually, my name is Hadi, as an engineer working in the University of the Nicola Cusano, collaboration with Professor Formisano in the University of the Federico II in the Naples. Our research is entitled the sismic retrofitting of the masonry walls using the regular steel grids and steel web plates. As you know, that their masonry structures has a lot of the problems in the failure phenomenons. Actually, when is subjected to the horizontal forces. So our content is going to understand the metal-based reinforcement system. And for this reason, we consider just four kinds of the finite element analyzing, starting from the linear, buckling analyzing, go ahead with the pushover analyzing of the single steel plate. Then we are going to combine this kind of the reinforcement of the masonry wall by the validation of the experimental combine. So by mentioning the three kinds of the common failure of the masonry wall, which is the sliding and rocking and the changing cracking, there have a lot of the reinforcement system, which is each one have the advantages, some disadvantages. It can be mentioned, and the most can be increase the ductility of the system of masonry because of the lack of the ductility. Most famous one is the steel element that used and attached for the structures. For this reason, we are going ahead with the activity of the Professor Bruno in the US, who is working on the concrete and masonry walls by adding the steel strips, as is shown in the figures upside with the cyclic behavior. It can be improved by adding the just 3 millimeter strips and at both sides. It's going to 5.5 times more in the shear strength and 7 times more in energy dissipate factors. Then in the Pakistan University, one of our colleagues works in the one and two sides applying the strips, steel strips, in the playing with the mesh sizes in the longer and the tight one. And as it's shown in the unreinforcement systems, as in the curve it can be seen white grain, it's going to adding the very tight steel strips. It's going to improve just the shear strength. When we are going to adding in the one side of the steel strips, it's going to not weigh much in the improving the seismic performance in the initial stiffness and the strength, but when we are going to add in the both sides, we are going to increase in the both initial stiffness and the shear strength. However, you can find two different kind of the failure phenomenon, and when adding in the one side and the both side, because of the out of plan issues of this kind of the bounding situation, because we have the length of the buckling in the steel strips, we can have very crucial issue in the out-of-plane displacement. That's why we are going to study in this topic to understand how can reduce it. So another one which is developed with my supervisor, Professor Formisano, is a skeleton system by adding on the reinforced concrete frame by filling with the masonry walls. Is going to show that adding this kind of system is differences on the shear strength is going to more or less around the 40%, and the laying and reaching the maximum force is going to the 66%, which is the very significant improvement in the seismic release. Now we are starting from our study to understand how can reduce this kind of the out of plan the grid tips, because of the everybody up to now to go to study from the elastic part to go to the nonlinear part, we are starting from the elastic part with the perforated just single plate. So by considering the steel full plate and adjusting some strips on side, the more crucial part can be rise in this moment is the link length, which is it can be vary and control the out of plane displacement. So by considering this and verification on the just linear buckling analysis, we can understood by increasing the opening ratio that is going to understand when opening is high, the link length effectiveness is very less. So if you consider just 100 or 50 millimeter is not very effective on the high opening ratios. Then next activity, and one methodology we used, instead of increasing, because one much more important parametric study of the steel is how can to solve the problem. Anybody can answer me increasing the stiffness. Yes, increasing stiffness is going to the optimization point of view, is going under question. How can to connect this element on the another element is going under question. So we are going to solve this problem just by grid plate and adding the dissipative. As shown in the top side in the 6 millimeter, we consider the rigid plate and adding the dissipative in such a way in the 1, 2, 3, 4, 5, 6, 7, 8, 9 places to understand how can influence on the seismic performance of this kind of the single plate. So we verified one just plate with the 1 meter length and adding the thickness of the 6 millimeter. As you show in the pushover curves, the seismic performance in terms of the initial stiffness and the maximum force is high in compared to grid perforation pattern. So how can to improve this? By adding the steel thin plate in such a way in the place, in the positions, we can decrease the out of plane displacement and improve the performance of the steel web plate. So my another supervisor, Professor de Matthes, who is developed in 2021 with his PhD students, Matthias Zizi, one macro model on the experimental combine and it's like the 1.5 length of this with the contribution, this combined experimental contribution of the Federico II under the supervision of the Professor Mazzolani and Romani University. They developed this combine. Then the macro model, by considering the several material properties as shown in the slides, applied for the finite element model by considering compression force and cyclic. Just we go to show the backbone curves of our study is going to show that there is a very good match between the experimental and finite element by adding the strips on the macro model. So for improvement, just we consider just single mesh without adding the dissipative system. As it can be seen here, yes, it's respected that with increasing steel mesh thickness, it can be increased the shear strength, yes. But please consider when you are rising to 30 millimeter of the mesh, you can improve just 40%, as it can be seen here, just 1.4. So our methodology by adding just the thin plate as a dissipative, it can be seen we can rise the seismic performance up to 2.35 instead of the increasing the mesh thickness. So this is the starting point of our study, and we believe that in next activity we can show more results related to this EDA, because EDA is very, very new, and it's welcome any another addition comments for our study. Thank you so much.
Thank you,